Good evening, children.
Good evening, ma'am.
Good
Good
evening,
evening.
ma'am. Good
Good
evening,
evening.
ma'am.
ma'am.
Good evening.
Ma'am, done
Good
with the
evening,
assignment which you gave, ma'am.
Swati?
Ma'am, no, ma'am. You told to write something in the notebook. No, ma'am. Completed
Correct.
that, ma'am.
Oh, very good. Very good. I hope all of us have completed the classwork. So,
Yes, ma'am.
completed the classwork, I mean,
Yes, ma'am.
what discussed in the last class. If you have taken screenshots, you should have completed them, written it out on your classwork notebook. Yes, somebody wants to say something? Am I audible, children?
Yes, ma'am. You're audible.
Yes, ma'am. You're audible,
Yes,
ma'am.
ma'am. Audible, ma'am.
Okay. We did discuss this in the last class. Take a screenshot and check your answers. This one was discussed in the last class. I didn't show you the answers, that's all. Take a screenshot and you can compare your answers. Done?
Yes, ma'am. Done.
Yes, ma'am. Completed.
All right. These, now that we have understood graphs in detail, children. Yes, I think yeah, this is also a simple one. Let me just talk about the ratio. Take a screenshot, children. This will be homework.
Done, ma'am.
All right.
Ma'am, good evening.
Good evening. Good evening, Matthew.
Ma'am, this we should do as a homework.
Yes, Nandana, yes. I think we have discussed graphs in great detail. So we'll not spend time on this again. Take a picture of this one and complete it by yourself.
Okay,
Yes, ma'am.
ma'am.
Yeah. But we'll just understand how we'll read every subdivision when the scale is 1 centimeter equal to 20 children. We'll just understand that. So now between 0 and 20, okay, let's take between 60 and 80. So between 60 and 80, how many subdivisions we have? Between 60 and 80, how many subdivisions?
Ma'am, 9.
9 subdivisions we have. Between 60 and 80, we have 9 subdivisions. Like we have 4 and then the middle line and again a 4. 4 lines, 4 small lines, the middle line, and again 4 small lines. So 4 plus 4, 8, the middle one, 9. Now we'll understand what value each subdivision takes or each subdivision holds between 60 and 80. We'll understand what value every subdivision holds between 60 and 80. So what's a scale? The scale, we are jumping in 20. See 0, 20, 40, 60, 80. We are jumping in 20s. So scale 1 centimeter is equal to 20 children. 20 children. Now we should always divide 20 by, you should divide the scale
10,
by
ma'am.
10. So
10.
what's the number you get?
2, ma'am.
2. Always divide the scale. Whatever scale you've chosen, always divide by 10. When you divide by 10, 20 by 10, you get 2. So after 60, so you'll have to count in twos. 2, 4, 6, 8, 10, 12, 14, 16. You have to count in twos. So when you have to count in twos between 60 and 80, you have to count in twos, not starting from 2. Between 60 and 80, you'll have to skip count in twos. Between 60 and 80, you'll have to skip count in twos. So it'll be 60 here. This is 60. The next one will be, children, the first division will be
62, ma'am.
then
64.
Then?
And then 66, 68, 80, 82, 84, 86, 88. Like that.
Ma'am, somebody
no,
mic is disabled, ma'am.
somebody's sitting in a place where it's noisy. Kindly, that particular student, please disable your mic. I don't know who it is. Please disable your mic. So let me tell you, 60 to 80. 60, the first subdivision, 62, the second one, 64, the third one, 66, the fourth one, 68, the middlemost one, the fifth one, 70. Somebody said after 68, somebody said 80, not 80, 70, 62, 64, 66, 68, 70. The middlemost line is 70. Continue counting in twos. 72, 74, 76, 78. You see here, you reach 80. The subdivision below 80 is 78 and 80. 60, 62, 64, 66, 68. The middlemost one is 70.
Ma'am, for 80 and 100 also 80, 82, 80.
Correct.
80
We'll count. Okay. Count. Yeah, count. After 80 it will be
82, 84, 86, 88, 90, 92, 94, 96, 98, 100.
Yeah. Did you reach 100 correctly?
Yes, ma'am.
Yeah. Now count 100. After 100, 100.
102, 104, 106, 108, 200.
No. 108 plus 2.
110, 112, 114, 116, 118, and then we have 120, 122, 124, 126, 128, and then 130, 132, 134, 136, 138, 140.
140. So between the numbers, you'll have to skip count in two. So if you start like, if you want to read the numbers between, this is 20. This is 40. You want to understand what value every subdivision holds between 20 and 40. This one is 20. This one is 40. Am I audible, children? Is my voice reaching you clearly?
Yes, ma'am. Yes, you're audible, ma'am.
Okay. So now this one is 20 and this one is 40. This is 20, this is 40. You don't know how to read these subdivisions which come between 20 and 40. That's what we did. Take the scale. The scale is 20, 1 centimeter, 20 children. Divide by 10, you get 2. So you'll have to skip count in twos. After 20, 20 plus 2, 22. You should not start from 2. Whatever is a number here, 20 plus 2, 22, plus 2, 24, plus 2, 26, plus 2, 28, plus 2, 30. Then 32, 34, 36, 38 and 40. Now if you want to read here, after 0, 0 plus 2, 2. 2 plus 2, 4. So here it will be 0, 2, 4, 6, 8, 10, 12, 14, 16, 18 and 20. And how do we decide the scale? How do we decide the scale? We look at the values here. How do we decide the scale? We look at the values here. The values are like 135, 120, 95, 100, 90 and 80. So looking at these values, we feel when we mark 10, 20, 30, 40, this one will be very tall. 135 will be very tall. Again, it's not wrong.
Ma'am, we can use 5 table.
No, 5 times 15.
Ma'am, the scale we use should not affect the bar graph's height, ma'am.
Yeah. When you take 1 centimeter as 5, 1 centimeter as 5 children, this is what I suggest. Whatever comes to your mind, try it out. Only then when you see, you will realize that 1 centimeter, 5 children will be, meaning the rectangles or the bars will be too tall. It'll be very tall. You should try it. Roughly, try it. The bars should not be very small or very tall. So 5 centimeter, no. I wouldn't suggest 5 centimeter. Sorry.
Ma'am, can I tell?
1 centimeter is equal to 5 children? No. Yes, Anugraha?
Ma'am, 10, ma'am.
Yeah, 10 is also fine. 10 is fine.
Ma'am, 20 will do, ma'am, because all the number are mostly divisible by 20.
Yeah, 20 is also good. We can't say that 20 is the correct one. There's nothing like a perfect scale. For this one, there's nothing like a perfect scale. You can take 10. 10 is fine. 20 looks ideal for me. Again, you can take 10. Okay, it will be very tall. The rectangle, this 135 will be very tall. So I thought 20 will be ideal. Not be very tall, not very short. You shouldn't take 50s. You shouldn't take 1 centimeter is equal to 50 children. You should not take 50. 10, I wouldn't say correct. 20 for me looks ideal. Because if you take 10, 135 will be very tall. The rectangle will be very tall. It will be double the size. And to find the ratio, children, to find the ratio, you should just divide the two numbers. Read the question. We need to find the ratio here. To find the ratio, you should just divide the numbers 120 by 100. So when you cancel, when you reduce it, 0 and 0 will get cancelled. 12 by 10. 120 by 100. No, I have not read the question for you. You just have to find the ratio of these two number of students. So 120 by 100. 120 by 100, 0 and 0 gets cancelled. So 12 by 10. And 12 by 10 in the tables of 2, 6 by 5. Or the ratio 6:5.
Ma'am, can we
Yeah.
Ma'am, can we divide 100 by 120?
No, you need to find a ratio. This is what you should do. Cancel the 0. 0 and 0 will get cancelled. You have 12 by 10. And further dividing in the tables of 2, you get 6 by 5, which is 6:5. 6 by 5 is nothing but 6:5. So the required ratio is 6:5.
Ma'am, instead of dividing 120 by 100, we get 6 by 5, no, ma'am. Can we also divide 100 by 120, we get it 5 by 6? Is it also
No,
correct?
That depends on the ratio asked. You should find the ratio of the students of class 6th to the students of class 8th. So you must write 6th standard students first and then 8th standard students.
Yes, ma'am.
Whatever's first, like now, if you're asked to find the ratio of girls to boys, then you should write girls in the numerator and boys in the denominator. If you're asked to find the ratio of boys to girls, then you must write boys in the numerator and girls in the denominator. Whichever is mentioned first will come in the numerator. Whichever is mentioned second will come in the denominator. So here we'll have to find the ratio of the students of class 6th to the students of class 8th. Class 6th ratio, that means you should divide. Ratio, that is divide numerator by denominator. Ratio of what? Number of students of class 6th to the students of class 8th. So you can see here required ratio is equal to number of students in 6th class by number of students in 8th class. 6th class 120 students, 8th class 100 students. So because it's our 6th to 8th, so 120 by 100, which is 6 by 5 or 6:5.
Yes, ma'am, understood.
Right. Yeah, that was a good question also, Swati. Thank you. If the question was the other way around, find the ratio of the number of students in 8th class to the number of students in 6th class. 8th class to 6th class, then it will be 100 by 120.
5:6, ma'am.
Yeah, the ratios are different. 5:6 is different from 6:5. So the order is important. The order is important.
Yes, ma'am.
So children, so it's about taking a suitable scale. So here I have taken 1 centimeter is equal to 20 children, taking a suitable scale and then making the bar graph. That's the first thing. And answering the question is simple. You will not find it difficult. It's all answered here. Please go through and complete it in your classwork. Take a screenshot. See, what is very important for a graph is how to read the subdivisions. That's very important. And I think we have done enough. Complete the homework. If you still have a question, you can ask me in the next class. Take a screenshot and complete this in your notebook by the next class.
Yes, ma'am.
Okay, ma'am.
All right. So the performance of students in first term and second term is given. The performance of students in first term and second term is given. Draw a double bar graph, choosing appropriate scale and answer the following. So you'll have to draw a double bar graph. Look at the numbers 67, 70, 72. So that is English first term exam. First term exam out of 100. That is probably maximum marks 100. Maximum meaning maximum marks 100. See, that is not going to affect the graph. Maximum marks 100. Here also maximum marks 100. That is out of 100. 67 out of 100. 72 out of 100. This is the marks scored in the first term. This is second term. You'll have to draw a bar graph, a double bar graph, choosing an appropriate scale. So this is about one particular student, okay? The performance of a student, it's not of students. The performance of a student in first term and second term is given. The performance of one student. So one particular student has got these marks in the first term exam and these marks in the second term exam. One particular student has got these marks in the first term exam and these marks in the second term exam. What are we expected to do? We need to choose an appropriate scale and draw the double bar graph. Represent this information using a double bar graph. We have to represent this information using a double bar graph. You can see here.
Excuse me, ma'am.
Yeah.
Ma'am, in this double bar graph, you should club two bars and draw one, ma'am.
Correct. Because you for one subject English, you have 2 marks, 67 and 70. For this one subject,
Yes,
yeah, for this one subject English, you have 2 marks, 67 in the first term and 70 in the second term. So against English, for English, you must show one bar to a height of 67 and another bar to a height of 70. Since both the bars is of English, they must stick to each other like this.
Okay, ma'am.
Yeah.
Thank you, ma'am.
Yeah, welcome. So you can see the space here, and then this double bar graph for English. Again, that 1 centimeter space, double bar graph for Hindi. This entire thing is a double bar graph. Okay, two rectangles. Let me say double bars, 2 bars for Hindi. Then that space 1 centimeter. Again, 2 bars for maths. 1 centimeter, 2 bars for science. 1 centimeter, 2 bars for social science. And how tall they should be, you know how to read each subdivision. Now 72, you know where 72 comes. So to that height, you'll have to take the bar or the rectangle. What is empty is first term, and where I've crossed, I've used x's, no, x, 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 x. So that is that represents the marks in the second term. First term, second term, first term, second term. So see here, you should write that whenever you make a double bar graph, you must give that information that this empty one represents the marks in the first term, and the one which is crossed like this. You can, somebody ask me, can we shade? Yes, you can shade. You can shade. You can use dots. Okay. So,
Ma'am, and the value of each subdivision is 1, ma'am.
Correct. Correct. So here I have taken scale 1 centimeter is equal to 10 marks. So 10 by 10, 1. Each subdivision, you will have to skip counting 1. So like 70, between 70 and 80, there are 9 subdivisions. So 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, and 80. Okay. After making the double bar graph, these questions have to be answered. In which subject has a child improved his performance the most? In which subject has
Ma'am,
his
max, ma'am.
improved his performance the most? So
Ma'am,
here,
because
Max,
7
ma'am.
marks are being improved in max, ma'am.
yeah, because you can see when compared to this one is taller. But here, when compared to this one is only slightly taller. That means slight improvement. Here, no improvement. The child has gone down. Here, there is, when compared to this one, there is more improvement here. There's more improvement. The bar is more taller here. Here also slightly tall. Here slightly tall. So when you compare the second bars in every in all the rectangles, the second bars, you see that this one is more taller than the others. So the, or you can even see, actually you shouldn't see the marks. You must see the bar graph. But you can just double check, you can double check.
Ma'am, here 7 marks are increased, ma'am.
Correct. You can double check here. Here he's improved only by 3 marks. Here he's gone down. He or she has gone down. Here improved by 7 marks. Here 4 marks. Here 2 marks. So this is the, here only the improvement is the most. In mathematics, the improvement is the most. Because here in English, improvement is there, but 3 marks, only by 3 marks. Here no improvement, has gone down. In maths, improved by 7 marks. Here improved by 4 marks, improved by 2 marks. So the performance is, the child is perform, meaning that improvement in performance is the most in mathematics. And it's represented by, this one is more taller when compared to this or this or this. Slightly increased, slightly tall this is. Slightly tall. This is taller than when compared to these. In which subject is the improvement the least? In which subject is
Ma'am,
the
in
improvement?
social, ma'am. Because only 2 mark is improvement, ma'am.
Yeah, see, that means in which subject, that means there is improvement, but it is the least. That's what it means. In which subject is the improvement the least? That means there is improvement, but that is the least. Of all the improvements, that's the least. So here improvement is by 2 marks. Here 4 marks. Here 7 marks. Here 3 marks. So this is 2 marks. So in social science, are we all following?
Yes, ma'am.
What about the others?
Yes, ma'am.
Yes, ma'am.
Deepika, Deepshika.
Yes, ma'am.
For the others, Anugraha, Matthew, Nandana. Improvement is
Yes,
there.
ma'am.
Yeah. First term marks, second term marks. So there is improvement by 2 marks. There is improvement by 4 marks. There is improvement by 3 marks. There is improvement by 7 marks. So least improvement in social science. Has the performance gone down in any subject?
Hindi,
Yes,
ma'am.
ma'am. It have gone down in Hindi, ma'am. Because
Yeah.
no mark have been increased.
Yeah, see, it's gone down in Hindi. And you can see the rectangle here also. First term rectangle is taller than the second term rectangle. The first term rectangle is taller than the second term rectangle. That means in first term the child has done well, but in second term performance has gone down. That's why the rectangle is less taller. Yes, the performance has gone down in Hindi. And here, I think I told you first term, show the empty square. Second term, I've used cross. So just show 1 or 2 crosses and say second term. Scale 1 centimeter, 10 marks.
Ma'am, can we write the title that the performance of student in first term and second term?
Yes. Double bar graph showing the performance of a student in first term and second term.
Ma'am, one doubt, ma'am.
Yes.
Ma'am, we are doing bar graph now, ma'am.
Yeah.
Ma'am, for that we are doing for first term and second term. In other type of graphs, we can't measure the second term also, ma'am.
In other type of?
Ma'am, there are pictograph and line graph now, ma'am.
Correct.
In that and all, we can't measure two for each.
Oh, you cannot compare.
Yes, ma'am.
No. Comparison in line graph you can do, but not in picked up circle graph. Pie chart you cannot.
Yes, ma'am. Thank you.
Yeah. Taking a screenshot, children?
Yes, ma'am. Took.
So consider this data collected from a survey of a colony. Favorite sport: cricket, basketball, swimming, hockey, athletics. So what comparison you have here is if how many people like watching, how many people like participating. How many like to participate? How many like
most of them are only participating. No, least, ma'am.
Yeah, most of them like to watch. Yeah, so watching and participating. Okay, so now for this information, we need to draw a double bar graph, choosing an appropriate scale. And then these questions you have to answer. What do you infer from the graph? Which sport is most popular? And which is more preferred, watching or participating in sports? You'll have to answer these questions. Which is more preferred? Whether people like to watch sports or participate in sports?
Watching, ma'am.
Watching, ma'am. They are interested in watching.
Sport.
They are more interested in watching than in participating. So what is important is the scale. 1 centimeter. You can see the numbers. They're all in hundreds. 1,240, 470, 510. Ritika will answer my question. Just have a look at the numbers, the values, children. All in hundreds. 1,240, 620, 470, 320, 510. Okay, so they're all in hundreds. Now, Mritika.
Ma'am? Yes, ma'am.
Yeah. Now I want you to read the 9 subdivisions between 800 and 900.
Okay, ma'am.
Yeah. After
810. 810.
Okay, 1 minute. Mritika, why are you counting in tens? Why are you counting in tens?
No, ma'am. There is 10. Here I have given hundreds, ma'am.
Hmm.
So there are 800 and 900. There are.
Okay, good. You've understood. Okay, fine. You've understood. All right. Yeah, now read, Mritika.
810, 820, 830, 840, 850, 860, 870, 880, and 890, and 900.
900. Very good, Mritika.
Yes, ma'am.
Correct. Now,
Thank you,
children,
ma'am.
what is that I have told you? How do you find by which number you have to skip count?
Ma'am, since the scale is equal to 100 people, we have to always divide it by
There are
10,
10
ma'am. So
subdivisions,
100
ma'am.
divided by 10, we get 10, ma'am. So the value of each subdivision is 10.
10. So we have to skip count in 10. Correct. Can we do this? So now if you want to find 105, where is 105? Between 100 and 200. Supposing you want to locate 105. 105 is between, here it is, okay? It's here. 105 is between 100 and 200. But where is 105? It's between 100 and 200. But where's 105? After 100 is 110. Yeah. After 100 is
110 and
110.
100.
Yeah. So 100 is that main line. After that, the subdivision is 110. Between those two is 105. Even if it is 104, there only you will have to take. There is no exclusive position for 101, 102, 103.
Ma'am, we should estimate it, ma'am.
No, this estimate also, it's so difficult. There's no space to estimate also. That's that.
Okay,
See,
ma'am.
between, yeah. Now, this is 100. This is 100. The immediate subdivision is 110. There is hardly any space between the two. That only is 105. Between that is 105. Correct?
Yes, ma'am.
Yeah. So
Yes,
even if it was 103, there only you will have to take between 100 and 110.
Ma'am, and between 100 and 110, the midline, which is fifth line, will carry a value of 105, ma'am.
No, where will you find that midline?
Ma'am, no, ma'am, I'm saying, ma'am, the 100.
Okay.
100.
If you see it under microscope and yeah. Okay. Magnifying glass, I meant, yeah. Then you can see if you widen the space. But all that is not, we are not going to do all that, no? So let's not get into all that.
Yes, ma'am.
Now, what is the immediate subdivision after, 300?
310, ma'am.
310. Supposing there's a number 301. So 300, the immediate subdivision is 310. Between that, you'll have to take a line which is 301. Whether it is 301, 305, 309, everything has only one position there. All right, children, take a screenshot, complete this graph.
Yes, ma'am. Take the screenshot.
Ma'am, took screenshot, ma'am.
Okay. The questions are also very simple. See, which is the which sport is most popular? Which is the most popular sport?
Ma'am, cricket, ma'am.
Cricket,
Cricket is
ma'am.
the most popular sport. And which is more preferred? Because everywhere you can see watching. Everywhere you see watching rectangle is tall. Everywhere you see the watching rectangle is tall, but the participating rectangle is shorter than the watching rectangle. So that means
Yes,
watching is more preferred than participating.
Yes, ma'am. Ma'am, and we inferred that cricket is most preferred for watching and participating, and athlete is least for watching and participating, ma'am.
Okay, very good. Yes. Very few people like to take part in athletics. Most people want to take part in cricket. People who took part, people who participated, most of them participated in cricket. But the thing is, actually, this people of this colony should be appreciated. There are so many people participating also. This actually is a very good, response. There are people watching, but there are so many people participating also. So,
Will in one colony this many people will there?
Yeah, there are big colonies, no? Yes, yes. A colony itself, there are colonies which are like one
Like
independent
400
area
houses will
itself.
be there, ma'am.
Yeah, there are. Since we live in a small town like Trichy, for us it looks like, how can so many people live in a colony? Yes, there are. There are colonies where the bus has the government bus. There'll be 2-3 stoppings inside the colony. Colonies can be so big. Imagine that. The bus will enter the colony and there will be 2-3 stops. It can be that big, the colony. Okay. What will be the scale? Tell me, what's the scale?
Ma'am, 10.
Um,
Ma'am, 10.
Ma'am, the scale can be 2.
2. Yeah,
Ma'am,
it can
5.
be.
Ma'am, 5.
Yeah, 5, don't you think will be ideal, children? Yes. Because just use your fingers. 5, 10, 15, 20, 5, 10, 15, 20, 25, 30, 35, 40. There is 41 also. So like 8 centimeters you will take. That'll be an ideal height. Now see here. Now here there was one big value. See here. What is it? 5, 10, 15, 20, 25, 30, 35, 40, 45. Okay, 40 here. So the rectangle will be this tall. So that's enough. If you take 2, 4, 6, 8, 10, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, where is that 41 is there? It will be so tall. So 2 is not ideal. 1 centimeter, 2 units is not an ideal scale. 5 will do good because,
Ma'am, 5.
yeah, 5, 10, 15, 20, 25, 30, 35, 40, 45. So like this tall. Yeah, that's good. And again, it's a double bar graph. It's a double bar graph. So look, depending, how do we choose the scale? Depending on the values we have in the table. We choose the scale depending on the values we have in the table. So the values are like, they are small. Then there is no value greater than 41. There is no value greater than 41. You can see. Which is the smallest value?
Can you repeat it?
Yeah, no. What is the least temperature?
Ma'am, is it 21
Ma'am,
degrees?
21 degrees
Celsius, ma'am.
Yeah,
21 degrees
21.
Celsius.
21 is
21
the
degrees
least
Celsius.
temperature. And the maximum temperature?
41 degrees
41
Celsius.
degree, ma'am.
41
In Jammu.
1 degree
41. So
Celsius.
you can imagine the highest number you have, the highest value you have is 41. So you should, I hope we understand a scale of 5.
Ma'am, these and all we should. Ma'am, these and all we should write in classic.
Yes, you must do the graph. See, I have done it for you. You must do the graph. Now, one of you tell me, how will you read? Okay, let me ask Mritika again. Mritika, how will you read each subdivision? Now read
Ma'am,
the
I have a
subdivision.
doubt in that, ma'am.
Okay,
Ma'am?
fine. Yes?
Ma'am,
Shall I say?
in this,
Yeah, Mritika.
ma'am, in this, you told how to divide, read this subdivision, no, ma'am. If we divide a 10 by 10, it's 1, no, ma'am.
Where is 10 by 10? Yeah, 10 by 10 is 1, but here what is it?
5, ma'am.
No, let Mritika say. Mritika, tell me. Here is it 10.
Ma'am,
Here is it 10 by 10?
no,
The one.
ma'am.
Let me finish with Mritika. Mritika, yes.
Ma'am, you told to divide the scale with the 10, no, ma'am.
Correct. So it's 5 by 10, correct?
Okay, ma'am.
What is 5 by 10?
Ma'am,
0.5. 5 by 10 is 0.5, correct?
ma'am, how to count in 0.5, ma'am?
We'll do that now. Yeah, okay. So 5, no, do we understand 5 by 10 is 0.5, correct?
Yes, ma'am.
Okay, now let me ask Matthew. Matthew, read from 5 to 10. Mritika, how many divisions are there? Mritika, how many divisions are there between 5 and 10?
Ma'am, 10. 5, ma'am.
No, how many divisions are here between 5 and 10?
Ma'am, 9.
9.
There are 9 divisions.
Yes, ma'am.
There are 4, then the middle one, again 4, 9 in all.
Okay, ma'am.
See here, after 5, no, there are 4 divisions. Then the middlemost one. Then again 4 divisions. 4 plus 4, 8 plus 1, 9. Okay, Matthew, read. After 5, how will you read?
Ma'am, can you hear me?
Yes.
Yes, ma'am. I'm 0. 0.
Deepshika.
Yes, ma'am.
Yeah, read after 5.
Ma'am, 5.5, 6, 6.5. Ma'am, did you hear me, ma'am?
Yeah, I can hear you.
5.5, 6, 6.5, 7, 7.5, 8, 8.5, 9, 9.5, 10, 10.5.
No, yeah, thank you. Yeah. Thank you, Deepshika. So that's what it is. After 5, 5.5, 6. 6.5, 7. 7.5. See, there are 9 divisions. Between 5 and 10, there are 9 divisions. Between 5 and 10, there are 9 divisions. So after 5, 5.5, 6. 6.5, 7, 7.5. 7.5 is the middlemost one. Then after that, 8, 8.5, 9, 9.5, and then 10. Ritika? Got that?
Ma'am?
Did you get it, Mritika?
Yes, ma'am.
Now read from 25 to 30, Mritika.
Ma'am, 26.5, ma'am.
No, after 25.
26.5.
25.5.
25.5, ma'am. 26.5, ma'am. 27, 27.5, ma'am. 28, 28.5, 29, 29.5, 29.5, and 30, ma'am.
30. That's how you read. That's how you read the subdivisions between 25 and 30. Whatever is your scale, divide by 10, 5 by 10, 0.5. So if you want to read between 25 and 30, count 10, skip count 10, 0.5, 0.5. So after 25, 25.5, 26, 26.5, and so on.
Okay, ma'am.
All right.
Clear.
Yeah. Okay, Mritika. Good. Thank you.
Thank you.
Children, the other questions are easy, children. Take a screenshot. It's just English, which is the hottest and the coldest city and all that. Take a screenshot, complete this.
Took screenshot, ma'am. We can move.
Yes, ma'am, took screenshot.
All right. Children, so today is the compensation class. Last Friday, I did not. Yeah, last Friday, right? We didn't have a class. We didn't have our regular class last Friday, correct?
Yes,
Yes,
ma'am. Last
ma'am.
Friday only, ma'am.
Yeah. So this is the compensation class for last Friday's class. You all know it. I'm just telling you.
Yes, ma'am. Took screenshot.
Okay, children, since these questions are, completely in English, you can definitely understand them and answer the questions. That's why I'm not discussing. There's nothing mathematical here. So I'm sure you can help yourself. One of you read these statements.
Shall I read?
Yeah.
Shall I read?
Yes. Okay. One each.
Yes, ma'am. Introduction. In every life, we came across statements such as, most probably it will rain today.
Yes, Nandana.
Chances are high that the price of petrol will go up.
So chances are high. So see, the first one is most probably it will rain today because you're seeing dark clouds in the sky. You're seeing dark black clouds in the sky. So you're like, most probably it will rain today. Then chances are high that the price of petrol will go up. That means you are really expecting. If it doesn't go up, you'll be happy. You're actually now, oh my God, the price of petrol is already high. It's still going to go up. You're expecting that. Chances are high that the price of petrol will go up, but you don't know if it will go up or no. You have a feeling there. You feel there's a good chance that it will go up. So you're not, anything can happen. The price can go up, will not go up. You don't know, but you feel, or the market says that the chances are high for the petrol price to go up. The other one, I doubt that he will win the race. So you're looking at the performer and you feel, oh, he's going too slow. I doubt he'll win the race. So what are the words you see in these statements? You can see you've used the word probably, because you're not sure. It may not rain also. You don't know what will happen, but you feel, looking at the clouds in the sky, you feel most probably it will rain today. So look at that word probably. Chances are high. Chances are high. Again, there's a good chance, or the percentage that the price of petrol will go up is high, but you don't know if it will go up. Chances, I doubt. All these words, they suggest some uncertainty. You're not sure. These words, when you say it will rain today, it will, I'm sure it's going to rain today. That means you are expressing your, your expectation. You are expecting rain. It will rain today. That means 100% it's going to rain today. It is certain there. That means you are saying it is certain that it will rain today. But in these statements, you can see some uncertainty. Most probably it will rain today. Chances are high. I doubt he will win the race. So these words, most probably, chances, doubts, all these show some uncertainty. It shows some uncertainty in the. Yes, Nandana?
And it is an expectation.
Nandana, louder.
And we can tell that it is an opinion or expectation.
Can somebody tell me what she's asking?
Ma'am, she is saying that it may be an acceptation or anyone's opinion, ma'am.
Correct, correct. Yes, yes. That's what. This is somebody's opinion. Say this is Nandana's opinion. Most probably it will rain today. Yes, I might say it will rain today.
It's their perspective, ma'am.
Yeah, it is their perspective. Perfect. We're just taking some example statements. We're just taking some examples. In a certain example, it may be 100%. Sure, it might be 100%. That is, it may be certain that it will happen. Okay, so these words, they suggest some uncertainty. Now that's what we're going to learn in this chapter. The measure of uncertainty is called probability. The measure of uncertainty, the numerical measure of uncertainty is called probability. Probability is it's a huge subject. What we have is the very basic of probability. Even till we have this chapter right till 10th standard, but we'll be learning only the elementary concepts of probability. Very elementary. We have this in we have it 7, 8, 9, 10, all the standards. We have this chapter probability. But even in 10th standard, you'll be learning questions of very of simple nature. So probability is the measure of uncertainty. It's a numerical measure of uncertainty. Probability is the numerical measure of uncertainty. This uncertainty, you measure it. You can give a numerical value, and that is called probability. All right, the others are just for your reference, children. Take a screenshot, write out all this in your book. The numerical measure of uncertainty is called probability.
Yes, ma'am, took screenshot.
Yeah. All right. Now let's understand some terms used in this concept probability. Experiment.
1 minute, ma'am.
Earlier slide, huh?
Yes, ma'am.
Yeah. Done?
Done, ma'am.
All right. Now let's understand certain terms used in this, this particular concept probability. What is an experiment? Experiment is not, the experiment which we do in the physics or chemistry lab. An operation which can produce some well-defined outcomes. I'll tell you what every phrase in this definition means. An operation which can produce some well-defined outcomes is called an experiment. Each outcome is called an event. An operation which can produce some well-defined outcomes is called an experiment. Now say, I toss a coin. Okay, I roll a die. I roll a die. D-I-E, die is singular. D-I-C, dice is plural. I roll a die. This is an operation, meaning an act of, it's a particular activity. Operation itself is a verb, right? Operation is a verb. It's an action.
Yes, ma'am.
It's an act of doing something. That's what it is. An operation meaning an act of doing something. What am I doing? I'm taking a die and I'm rolling it. So when I roll it, the outcomes are well defined. You know, when you roll a die, you will get the outcome as 1 or 2.
And the result?
Yeah, outcome is a result. Yes, you will get 1 when you roll a die. The die may show up 1, 2, 3, 4, 5, or 6. So you know, right? One of these will happen. Do you know that or not?
Yes, ma'am.
Or is it, do you feel, I don't know when I roll? Yes, you don't know which of these 6 numbers will happen, but you know that one of these 6 numbers only will happen. Yes or no?
Which sure one? In that, ma'am.
Yeah, which one?
Yes, ma'am.
Which one of these 6 numbers you don't know, but one of these 6 numbers only will happen. That is why we say well-defined outcomes. Well-defined outcomes meaning you know the outcome is, once you roll the die, the outcome is the result you get. The result can be a 1, it can be 2, 3, 4, 5, or 6. So when you roll a die, the outcomes are well defined because you can get a number from 1 to 6. The outcomes are well defined. That is what it is. That is an experiment. So when you roll a die, the act of rolling a die is called an experiment in probability. An operation which can produce some well-defined outcomes is called an experiment. Each outcome is called an event. Which are the outcomes? 1, getting 1 is an event. The event of getting 1. The event of getting 2 when you roll a die. The event of getting 3 when you roll a die. The event of getting 4 when you roll a die. The event of getting 5 when you roll a die. The event of getting 6 when you roll a die. Every outcome is called an event. Every outcome is called an event. Well-defined outcomes meaning you know that you will get, when you roll a die, you are sure you will get, the die will show up 1, 2, 3, 4, 5, or 6. It cannot be anything out of these numbers other than these numbers. So well-defined outcomes. Each outcome here is called an event. I told you the event of getting 1 on rolling a die. The event of getting 5 on rolling a die. So that is an experiment. An operation which can produce some well-defined outcomes is called an experiment. Each outcome is called an event. One is an outcome. When you roll a die, doing that act is an experiment. When you roll a die, that's you're performing an experiment. What are the results? What can be the outcome of that experiment? Getting 1, getting 2, getting 3, getting 4, 5, or 6 is an outcome. Each of these outcomes is called an event. Each of these outcomes is called an event. All right.
Ma'am, like same. Ma'am, like same when we toss a dice and we get head or tail, like that.
When you toss a coin, yes. When you toss a coin, you'll either get a head, the coin will show up head or tail. Let's see what a random experiment is. An experiment in which all possible outcomes are known and the exact outcome cannot be predicted in advance is called a random experiment. A random experiment. There's no much difference between an experiment and a random experiment. An experiment is a random experiment. So see, when you're performing an experiment, when you're performing some act where you don't know what will happen at all, that is not that doesn't come under the study of probability at all. When you're studying probability, you're performing an experiment where you know the outcomes. You know that one of these will happen, but you don't know which one will happen. You know one of these will happen, but which one will happen, you don't know. That's exactly what a random experiment is. An experiment in which all possible outcomes are known and the exact outcome cannot be predicted. What exactly will happen? So when you roll a die, what all is possible, you know, but which one will happen when you roll it at that time, that you cannot say, that you cannot predict in advance. Before rolling the die, you cannot say, I'm going to roll the die and it's going to show up 4. You cannot say that in advance. That's a random experiment. An experiment in which all possible outcomes are known and the exact outcome, what exactly will happen, cannot be predicted. You cannot say that in advance. It's called a random experiment. All these words are closely related, so don't get worried as to what is the difference. Trial. By a trial, now you say, no, okay, let me try. Don't you say, okay, let me roll a die, let me try. Trial. By trial, we mean performing a random experiment. Will you not say, okay, give me the die, let me try, let me roll and try if I can get 5 on it. So trial is trying, trial. By trial, we mean performing a random experiment. When you perform it, it's called a trial. By trial, we mean performing a random experiment. A random experiment is one in which you know all the outcomes. Now, for example, when you have a pack of playing cards, you know there are 52 cards and one of those 52 cards you're going to pick. You know the possible outcomes, but what exactly? So from the 52 cards, when you pick one card, which card you will get in your hand, that you cannot say in advance. But you will know the outcomes are fixed. You will be getting one of those 52 cards. So the act of picking one card from a pack of 52 cards is also a random experiment. You can say tossing. So you can give some examples of experiments. Tossing a coin. When you toss a coin, you're performing an experiment. It's a random experiment. When you toss a coin, you know the coin will show, it will show up head or tail. But which one it will show, that we don't know. But you know it will be head or tail, but which one you don't know. So the outcomes are well defined, head or tail, well defined outcomes. But which one you don't know in advance. So it's a random experiment. Similarly, when you roll a die, 1, 2, 3, 4, 5 or 6. So the outcomes are well defined. But which one you will get when you roll the die, that you cannot say in advance. That is why it's a random experiment. But in the chemistry lab, when you mix something and something, you know the outcome is going to be this. That's not a random experiment. That's not a random experiment. In the chemistry lab, so some parts of something and some parts of something you mix to get some parts of something. Correct? You mix two things to get something. In a chemistry lab, the outcomes are well defined. You know, when you mix two things, the product is going to be something.
Ma'am, the exact outcome can be predicted, ma'am.
Yes. So that's not a random experiment. The experiment performed in the chemistry lab, where the teacher knows what the final result is going to be. If the student performs the experiment correctly, takes the right amount of every substance, mixes, the teacher knows that this only will be the result. The student will not know, the teacher will know. That is not a random experiment. Okay. So take a screenshot, children. All this you can read for yourself. I think this is over. Yeah, take a screenshot of this one. Random experiment trial.
Took, ma'am.
Yeah.
I'm like
Oh,
a
so
trial is trying something.
Trying some, yes. You just when you see when you throw a coin or performing a random experiment. When you perform a random experiment, it's a trial.
Ma'am.
When you perform a random experiment, it's a trial. So these are some experiments. Throwing a coin. Take a screenshot.
Took, ma'am.
Take a screenshot.
Took the screenshot, ma'am.
Yes, I'm done.
This is throwing 2 coins. You can understand this. Read this. When you throw 2 coins, what are the possible outcomes? Both the coins can show head, or both can show tail, or the first one will show head and the second one will show tail, or the first one will show tail and the second one head.
Ma'am, vice versa.
So this all is possible. When you throw 2 coins in the air, when they land on the ground, both the coins can show head, HH, or both tail, TT, or the first coin head, the second coin tail, or the first coin tail and the second coin head. Nothing other than this you can get. So it's a random experiment. Throwing 2 coins is a random experiment because you know the outcomes. You know what all you can get, but what exactly you will get when you toss 2 coins, you don't know. You cannot predict the outcome in advance, but you know all the possible outcomes. You know these are the possible outcomes. These are the possible outcomes that you know. But which one of this will happen when you throw the 2 coins, that you don't know. You cannot predict the outcome in advance. So it's a random experiment. Throwing a die is a random experiment. Take a screenshot.
Took, ma'am.
Yeah, so you know when you throw a die, you will get a 1, 2, 3, 4, 5, or 6. Now, when we say on rolling a die, getting a number less than 7, what do you think of the statement? When you roll a die, what is the chance that you will get a number less than 7? When you roll a die, what is the chance that you will get a number less than 7?
Ma'am, because there is only 1 to 6 in the dice.
So 100% you will get, right? So when you roll a die, when you roll a die, getting a number less than 7, that you will definitely get. When you roll a die, you will get the number can be 1, 2, 3, 4, 5, or 6. That means the number which you get on the die will always be less than 7. So it's a sure event, or it's a certain event. And its probability is 1. 1 means it is sure to happen. The sun rises in the east. It's a sure event. You don't have to check every day. You don't have to keep your fingers crossed if the sun is going to rise in the east. The sun does rise in the east. Every day it rises in the east and sets in the west. So it's a sure event. Now I give you a calendar. I give you a calendar of year 2000. And I say, check if the number of days are less than 367. You don't have to check. Why will you check? You know in every year, the number of days It can be 365 or 366 if it's a leap year. Now I give you some 100 calendars and I tell you check and let me know in which calendar there are 367 days. What will you say?
I mean,
You will
all
not
calendar there is, ma'am.
yes, in all the calendar you will not check it all. You will say I'm done. I finished checking. You will say I finished checking because in all the calendars there will be the number of days will be less than 367.
Ma'am, and if they ask which month have 29 days, we don't say it is February, ma'am, because all day have 29 days.
Correct. So certain things are 100% true. So we say that the probability of a sure event, the probability of a sure event is 1. The probability of a sure event or a certain event is 1. The probability of an impossible event is 0. That is, if you say you roll a die, what is the chance that you will get a number greater than 7? You roll a die. What is the chance that you will get a number greater
Ma'am,
than 7?
100%.
No, ma'am, it's impossible to get a number greater than 7.
Yeah, when you roll a die, you cannot get a number. In fact, you cannot get a number greater than 6. You can get 1, 2, 3, 4, 5 or 6. You cannot even get 7. So it's an impossible event. When you roll a die, getting a number greater than 6 is an impossible event, which means the probability is 0. The probability is 0.
Ma'am, and the sun rises in the west.
Sun
It's
rises
also
in the
0.
west. Probability is 0. It will never happen. So probability.
Yes.
If an event can never happen, the probability is 0. If the event is sure to happen, it's certain to happen, 100% it will happen, then the probability is 1. The probability of an impossible event, you know, that cannot happen. That cannot happen. The probability. So now the probability of having school from 9 o'clock in the evening, 9 p.m. to 3 a.m. Evening, 9 o'clock to 3 early morning. Is it possible to have school?
No, ma'am. No probability, ma'am. It's 0.
No probability,
Zero.
ma'am.
So when
Ma'am,
you know,
0.
yeah, when you know for sure that cannot happen, that is impossible, then the probability is 0. But when you know that something is sure to happen 100%, when you that's what in the case of rolling a die, getting a number less than 7 is a sure event. You will get a number less than 7. It's a sure event. So we say the probability of an impossible event is 0 and the probability of a sure event or a certain event is 1.
Ma'am, and like we say, like small creatures like ants, insect can grow up to humans' height, ma'am. That is
Yeah,
also impossible.
impossible. Yeah. An ant which is 15 centimeters in length. Okay. Actually, I have another class now, children. I want to just take a screenshot of this one. The tests on probability and a few other topics are ready. I'll all this today, whatever happened is actually very simple. You can revise it by tomorrow evening, and I think on I'll activate the tests today, children. Today I'll activate the test. You revise and once you're confident, you can take up the test. I'll keep it open till Sunday. All right. I'll keep the test open till Sunday. Portions this chapter
Okay,
only.
ma'am.
This
Ma'am,
chapter.
probability.
No, this chapter. Yeah. Probability
Ma'am,
also.
only data
Probability.
handling.
Yeah, data handling. Only data handling. Correct.
Yes, ma'am.
Ma'am,
Only data
till
handling.
probability.
Correct. Till probability. Correct.
Okay, ma'am.
Yes, ma'am.
Yeah.
Ma'am, can we leave?
No. Take a screenshot of this one.
Took, ma'am.
All right. Now
Took
answer these
screenshot.
questions. Yeah. Answer these questions. There are 6 marbles in a box. Okay. There are 6 marbles in a box. What is the probability of drawing a marble with number 2 on it? See now, just imagine a box, okay? There's a box. There are 6 marbles in it. 6 marbles. The marbles are marked 1, 2, 3, 4, 5, and 6. Got that? There are 6 marbles. Every marble has a number on it. 1, 2, 3, 4, 5, 6. Every marble has a number on it. Understand? Every marble has a number on it. Yeah. Now, what is the chance or what is the probability? Now you are asked to take one marble from the box. You are asked to take
Ma'am,
one
it
marble
is
from the box.
100.
Sorry?
Is it 100, ma'am? Because you're telling 1 to 6. So
No. That's what. 1 minute. Now you have to put your hand in the box and pick one marble. But that marble should have the number 2 on it. What is the chance? What is the probability? So how many marbles have the number 2 on it?
Ma'am, one marble, ma'am.
One marble, ma'am.
Only one marble,
Totally, how
ma'am.
many marbles are there?
only one.
And 6 marble, ma'am.
6 marbles are there.
6
ma'am.
marbles.
Probability. The probability is 1 by 6. The probability is 1 by 6. I'll tell you again. The question is, or the situation is, in a box, there are 6 marbles. Understand? Understand? In a box, there are 6 marbles.
Yes, ma'am. Understood.
Okay,
Now,
ma'am.
on every marble, there are numbers. On one marble, there's the number 1. Another marble, number 2. Another marble, number 3. So on till 6. 1, 2, 3, 4, 5, 6. Now, you have to put your hand in the box and take only one marble. What is the probability that the marble which you pick will have the number 2 on it? The marble which you pick have the
Yes,
number 2
ma'am.
on it. No, wait, let me finish. So, how many marbles are there with number 2? How many marbles?
Ma'am,
Ma'am,
there are
it is
totally
one
6
marble.
marbles, ma'am.
How many marbles have number 2 on it?
One
Only
marble,
one
ma'am.
marble have 2
Only
in
one
them,
marble.
ma'am.
Totally, how many marbles are there?
6
marbles
marbles.
are there, ma'am.
So, 1 by 6 is the probability.
Yes, ma'am. Understood.
Ma'am, that means for second one also the answer will
So
be
it's
1 by 6,
no,
no, ma'am?
Correct, 1 by 6. Because again, because you're taking only one marble, you put your hand in the box and you're taking one marble. So how many marbles have the number 5 on it? Only one marble
Ma'am,
has
again
number
one.
5 on it. Yeah. Totally, how many marbles in the class? I'm sorry, in the
6
box.
marbles, ma'am.
6. So 1 by 6 is the probability.
Ma'am, if there is 8 marbles, it is like 1 by 8 and so on.
Correct.
Yes, ma'am.
Now, supposing a class has, supposing there are, we have seen this in fractions, supposing in a class there are 5 girls and 10 boys. 5 girls and 10 boys. Totally, how many students?
15, ma'am.
15. 15 students. So don't you say 5 out of 15 girls, 10 out of 15 boys?
Yes, ma'am.
5 girls out of 15 students, 10 boys out of 15 students. Same way here. There is only one marble, number 2. So only one out of 6. 1 out of 6. There's only one marble with the number 5 on it. So 1 out of 6. So 1 by 6 is the probability for both. Take a screenshot.
Good, ma'am.
Okay. Sorry. Okay. A coin is flipped. That is, you toss a coin to decide which team starts the game. A coin is flipped to decide which team starts the game. What is the probability that your team will start?
Ma'am, the coin has head and tail, ma'am, which is 2. So any one will only come, ma'am. Whether head will come or tail will come, ma'am. So it will be 1 by 2.
Correct. Swati's given. Swati's done my job. Thank you, Swati. Correct. So when you toss a coin, there are two possible outcomes. Either the coin will show up head or it will show tail. H or T. So maybe you'll get H or maybe you'll get T. So totally, so like in the earlier question, in the box, totally how many marbles? 6 marbles. Totally 6 marbles. So here totally how many outcomes? 2 outcomes. But how many will you get? It will be only one at a time. It will be either H or T. So 1 out of 2. If you get head, 1 out of 2 outcomes, head and tail, 2. See, like totally you have 2 outcomes, head and tail. So 2. But you will get only one of the 2 outcomes. Either you will get head, either the coin will show H or it will show T. So any one you will get, any one. So 1 by totally 2 outcomes. So 2, 1 by 2. For H also it is 1 by 2. For T also it is 1 by 2. Even if you get head, 1 by totally 2. For tails also it is 1 by totally 2. Half meaning 50% chance. 50% chance you have. Half meaning 50%. You have 50% chance to start the game.
Yes, ma'am.
All right, children. All right, children. So that's it for today's session. We'll have a regular class on Friday morning. Thank you so much. Please complete your classwork. Thank you, children. You may leave the meeting.
Thank you, ma'am.
Thank you, children.
Thank you, ma'am.
Thank you. Thank you, children.